Hello everyone, this is Dr. Zach. Today we are going to work with the second fundamental theorem of calculus, and since of course it is a fundamental theorem, you know that it is important. Let's get started. Your lesson preview provided you lots of opportunities to follow the order of operations and recognize that certain things are happening as you do your substitution. Capital F of 0 is going to be the integral from 0 to 0. You are replacing the x values. That is going to be great. Leave your t's exactly where they are. And in capital F of pi over 3, you're going to follow the similar ideas. This is going to be equal to the integral from 0 to pi over 3. But then you're left with the cosine of t dt. Now, the antiderivative of your cosine of t is the sine of t, and you're going to evaluate this from 0 to pi over 3. So if you follow the order of operations, these problems should be fairly straightforward. And when we're looking at question B, the question is asking you for a derivative. Now the derivative, once again, we're going to follow the order of operations. We need to find f prime of x. And in order to find that, let's see what happens. F prime of x is going to be equal to the derivative. The notation we'll use is d dx to indicate that we're going to find the derivative of whatever answer we get for this complex function. But you know that the antiderivative of your cosine function is going to be equal to your sine function. You just demonstrated that on the last problem. So we now have the sine of t, but it's going to be evaluated from pi over 2 to x to the third. So following the order of operations, do your substitution next. You will end up with your sine of x cubed minus the sine of pi over 3. Now from here, what is the derivative of sine of x cubed? Well, that, of course, is your cosine x cubed times your 3x squared. And what is the derivative of sine of pi over 3? Well, you know that's a number, so it's going to be 0. So what is the derivative of an antiderivative? Let's look again. Your answer for the derivative of f prime of x is your cosine of x cubed times your 3x squared. So for this problem, see if you can figure out how to go from the derivative of f prime of x, either using the order of operations or directly to your answer. The lesson preview sets us up beautifully to understand the second fundamental theorem of calculus. If we were to let the antiderivative of 1 over tangent t plus 1 equal f of t, and then evaluate it from 0 to x, that's going to help us when we follow the order of operations to understand what's happening in our problem. We would then look for d dx of f of x minus f of 0. But d dx of f of x is f prime of x, and the derivative of f of 0 is just 0. But what does f prime of x equal? F prime of x is equal to 1 over the tangent of x plus 1. So the derivative of the antiderivative is going to be substitution, and we'll end up with our function. For question number 2, you're told that f of x is equal to this integral from 0 to x cosine t over t cubed plus 3. First, we're looking for f of 0. Use substitution. F of 0 is going to be the integral from 0 to 0 cosine t over t cubed plus 3 dt. And you know that the integral from 0 to 0 is, of course, 0. Now we need f prime at 0. But before we can find f prime at 0, we need f prime of x. So f prime of x is asking us to find the derivative of an antiderivative. And we just practiced that. We know that f prime of x is the substitution cosine x over x cubed plus 3. Now specifically, we're looking for f prime at 0. When we substitute, we're going to have 1 over 3. Our third question asks for f double prime of x, which involves a quotient rule. And don't forget the derivative of the cosine is negative sine. And we'll multiply by 3x squared over our denominator squared. Next, we're specifically asked to find f double prime at 0. You're going to substitute and end up with 0. So as you think about each problem, make certain that you follow the order of operations and substitute accurately. So let's examine example 3. You could find the antiderivative of t to the third plus 2. Or I can just call that f of t. And I want to evaluate f of t from a to 5x to the third. So now, if I find a derivative of my function, I'm going to first substitute in f of 5x cubed minus f of a. But then when I find the derivative of the antiderivative, I get f prime of 5x cubed multiplied by 15x squared using the chain rule, and then a derivative of 5a. But what exactly is f prime of t? Remember, f prime of t is t cubed plus 2. So, put it all together. What we're going to have is substitute 5x cubed. That gives us 5x cubed to the third power plus 2. And we're going to multiply that function by the derivative of 5x cubed, which is 15x squared. So this is our second fundamental theorem of calculus. If we're finding the derivative of an antiderivative from some number to x, then the answer is f of x. If you're finding the derivative of the antiderivative and your upper endpoint is some function with respect to x, then we're going to take the function substituted with that u multiplied by u prime. All right, so for our last example, number 4, we want the derivative of the antiderivative of cosecant t. You don't actually know the antiderivative of cosecant t, but you do know from the second fundamental theorem of calculus, this answer is cosecant 5x cubed multiplied by 15x squared. Okay, so work for the next 20 minutes on the given set of problems. Once you've completed your problem set, you should check through some of your answers. So go ahead and turn the video off now to practice for a few minutes. All right, so make certain that you've checked question B and that you do not have a horizontal asymptote. You have an oblique asymptote at y equals 4x minus 8. Just a reminder that displacement is the antiderivative of velocity and that total distance is the antiderivative of the absolute value of the velocity. So first you determine the values at 0, 2, 4, 6, and 8. Make certain that you're using precise notation. To determine where a function increases or decreases, you want to look at your derivative, and that's where that second fundamental theorem of calculus comes in. You should know there's a relative min at x equals 4, because that is where you are changing from, your derivative is changing from negative to positive. And from your table of values, you can determine that there is an absolute min at 4, negative 8, and an absolute max at 8, 4. And lastly, sketch a rough graph of G. So today's lesson follow-up, you're going to practice that second fundamental theorem of calculus, and I hope you have a fabulous day.